is a peculiar section. Look at this title. Problems without solutions? What? Well, then why are we doing them? Well, if you look at the objective, you see the objective is to recognize problems that do not have solutions. Either not enough information is given, the given facts lead to an unrealistic result, negative distance, other situations dividing by 0, or this is the hard one, given facts are contradictory. They cannot all be true at the same time. So this will definitely be one of the more challenging ones, only because there's a lot of iffy things. What do you mean iffy? Well, meaning we're unsure of whether the answers, it's not straight up, very straightforward, simple answers. So we will give it our best, and we will try to come up with the right answers. Now that is very interesting. Oh, this is book 2, that's why. I was wondering. That's book 2 solutions. Let's look for book 1 answers. Well, we will again try our best in providing proper answers and giving it our best shot, even though I do not have the, do I have the answer key? I don't have the answer key, but we'll try it. I'm sorry. Here we go. Let's look. On a trip, oh, that's example 1. All right, we're not even going to work on example 1 or 2. We're going to get, or 3, we're going to get right to it. You plan a lawn 10 feet longer than it is wide. Okay, let's do green because lawns are green. 10 feet longer than it is wide. If it's W wide, then it's going to be W plus 10 in length. It is to be surrounded by a flower bed 3 feet wide. Okay, I get that, a flower bed. Flower beds are typically pink flower. So by a flower bed 3 feet wide. So it's 3 feet. That distance is 3 feet. This distance is 3 feet. This distance is 3 feet. So the new length and width is going to be W plus 10 plus 6. I have students who want to be in my movie again. They're very, very needy. They're constantly trying to gain my attention, which is fine, and I've got a lot of patience for it. Because they don't hear my voice enough, so they come back even during their free periods just so they can hear me talk to them. Find the dimensions of the lawn if the flower bed covers 80 square feet. So this, that's not right. Where's my pink? Goodbye, ladies. Have a lovely afternoon. If this area is 80 square feet. So we remember how to find that space. It's the area of the total, meaning the bed and the lawn, minus the area of the lawn should equal the area of the flower bed. Okay, so area of the total is going to be the big outside, so that's W plus 6, the length times the width, 16, because W plus 10, that's our width, minus the area of the lawn, which is W times the quantity length times width is, that should equal the area of the flower bed. And they said the area of the flower bed is 80. Okay, we get it. So let's multiply this out. That's W squared plus 22W plus 3696 minus W squared minus 10W gives you 80. Now let's simplify the left side. The W squares cancel. You're left with 12W plus 96 equals 80. Now we're going to solve for the variable. Subtract 96, we get 12W equals negative 16. 16, yep, good. And now let's divide by 12, and we get W, the width, equals negative. More students. Everybody's just dying to be in this video. 1 and what's that, 4/12, or W equals -1 1/3, and what's the unit? Unit is feet, and what's wrong with that? Well, we can't have negative distance. Can't have negative distance. So that width, the width of the lawn can't equal -1 1/3 feet, okay? So that's why that does not work. Let's try number 2. A bank teller was asked to cash a check for $180 and to give the customer the same number of $10 bills and $20 bills. How many bills of each kind did the teller count out? So we know that the total is going to equal, the total amount is going to equal $10 for every, we're going to multiply $10 times every $10 bill, and we're going to add it to 20 times every $20 bill. Well, why didn't I have, well, actually, let's do this. We can do times little t and 10 and 20, those are same. So T for 10, W for $20 bill. And what do we know about? We have the same number of $10 bills and $20 bills. So that's why I did 10x plus 20x equals the total, which was $180. So we have $180 equals 30x. Let's divide by 30, divide by 30, and we get 6 equals x. Okay, so how many bills of each kind did the teller count out? Bank teller, customer, blah, blah, blah. So let's check it. If we have 6 $10 bills plus 6 $20 bills, does that equal $180? That's 60 plus 120 equals 180. 180 equals 180. So it did work. This problem did work. You did get it. You would have 6 $10 bills and 6 $20 bills. So problem number 2 did have a solution. So they kind of tricked us. Number 3, in the course of a year, the sum of an investor's gains and losses was $2,400. What were his gains that year? Well, it's going to be gains plus losses equals 2,400. If we wanted to find out the gains, we would subtract the losses, and gains equals 2,400 minus minus losses. Yeah, that's kind of a trick because your losses are going to be negative. There's 2 ways, but I'm just going to do gains plus losses should equal 24, just with the understanding that losses are going to be recorded as a negative number. So you'd insert a negative number, and then you'd have the 2 negatives, which would make positive. But what were his gains? We don't have enough information. So we can't find it because there's not enough, N-O-U, enough information. We know nothing about the relationship between the gains and the losses. Maybe if they were double, etc., we could be able to find it, but there's just not enough. Find 3 consecutive integers whose sum is 47 more than the largest integer. This is a great one. First number is going to be n. Second number is going to be n plus 1, so consecutive integers. So third number is going to equal n plus 2. And so we're going to add those. N plus 1 plus n plus 2 is going to equal 47 more than the largest integer. So 47, so we'll take the largest and we're going to add 47 to it. So that's our problem right there. We have 3n plus 3 equals n plus 49. We're going to move the variables to one side. We're going to move the constants to the other. 2n equals 46. Divide by 2, divide by 2. And we get n equals 23. N is going to be our first number. So our first number is going to be 23, then 24, then 25. Does 23 plus 24 plus 25 equals 25 plus 47? Let's check. So we will check over here. Does 23 plus 24 plus 25 equal 25 plus 47? That's going to be 7. That's going to be 12. That's going to be 72. Does 72 equal 72? Yes. So those are my three numbers. 23, 24, and 25. Find three consecutive integers, so I need to list the numbers. So that one did have a solution. Find two consecutive integers whose sum is 48. We know any consecutive integers are not going to be an even number because consecutive is going to have an odd plus an even. Odd plus even is always going to equal odd. Don't know if you knew that. But so how do we write that? Well, this is the way we would do it. The first number equals n. The second number consecutive, so equals n plus 1. So the sum of those two equals 48. So we get 2n plus 1 equals 48. Minus 1, 2n equals 47. Divide by 2. We get n equals 23.5. That is not an integer. Not an integer. That's a partial number, so that's why no solution for that one. Chan bought more 25-cent stamps than 15-cent stamps. How many of each kind did he buy if the total cost of the stamps is $7.80? That's not enough information. Yeah, we know we bought more, but we still don't know how many more. We would need to know how many more or some relationship between the 25-cent stamp and the 15. Need more info. So that would be 0.25 times the 25-cent stamp plus 0.15 times the 15-cent stamp is going to equal $7.80. That's our equation, but we have no understanding of the relationship. We know that T is greater than F, but that doesn't help us. That doesn't give us any answer. Okay, so there are multitude of solutions. Hans has as many dimes as quarters. So now we see the relationship. We know the relationship. The dimes and quarters total $10. How many of each kind? So we know that dimes plus quarters, we take 25 cents times the number of quarters, is going to equal $10. And we know that dimes and quarters are the same, so we can give it the same variable. Equals 10. Let's combine those. 35x equals 10. Divide by 0.35. Divide by 0.35. X equals, so 10 divided by 0.35 gives us 28.57, blah, 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 blah. And what do we know? Well, we can't have partial. No solution because you can't have part of a dime or quarter. So it must be a whole number. So this one is no solution also. Last month, Charlene worked as many 8-hour shifts as she worked 10-hour shifts. How many 8-hour shifts did she work last month? Well, she worked, how many? She worked the same number as 10-hour shifts, but there's not enough. So we know that they work the same, but we don't know how many 10-hour shifts. So not enough information provided. So yes, we know the relationship, but we don't know anything more about last month than how much money or something like that. Georgette has the same number of 25-cent stamps as she does 15-cent stamps. Yep, we've seen that. So we know that, we know that. 6 times the value of the 25 stamps is $1, more than 10 times the value of a 15-cent stamps. How many of each type of stamp does she have? Okay, all right, so she has X25, same number of stamps. So we know how much, 6 times the value is $1 more than, okay, so 6 times the value of the 25-cent stamps. So if we take this and multiply it by 6, because this is the value, is $1 more, than the 10 times the value of the 15-cent stamps. So if we add $1 to the value of the 15-cent stamps, then we're going to get the value of the 25-cent stamps. So this is 150x equals 1.5x plus 1. That's interesting. So if we subtract 1.5x, subtract 1.5x, we get 0 equals 1, which is not the case. So we know that this is no solution. If a problem has no solution, explain why. Because no number of 25-cent stamps times 6 will ever equal that same number of 15-cent stamps times 10 plus 1. So that doesn't work either. And last one. Last month, Theo worked the same number of hours on 8-hour shifts as he did on 6-hour shifts. We've seen that. 1/4 of the amount of time he put in at 8-hour shifts was 1 hour less than 1/3 of the time he put in at 6-hour shifts. I hope I added. I'm just going back to the 6 times the value is $1 more. Yeah. Then that's 1 more than that. Yeah, that was right. I added the 1 in the right place. So same number of 8-hour shifts. So 8-hour times the number of shifts. 1/4 of that time. That's the 8-hour time. Was 1 hour less than 1/3 of the time he put in the 6-hour shift. So if we subtract, it was 1 hour less. That's 1 hour less. Yeah. We'll see if this works. So that's 2s equals 2s minus 1. See, we did it again. So this again comes out. Well, either way, even if I put the 1 on there, how many hours did he work at each shift? So both times it didn't work? 1/4 of the amount of time he put is 1/3. They both come out with 2s. That's a stinker. Well, let's look. Let's do this while we're here, because Mr. Mac does have Answer keys, 10 answer. Let's look and see what they say. Let's just check, It's not the worst thing to check our answers. Oh, okay. Yep. Not enough, not enough. All right. Not enough, not enough. Yes. Okay. Good. I'm good. I'm all right. I worked it. Yeah, same reason. Whew. Questioned myself a little bit there. Minus 2s, you get 0, doesn't equal -1. So that again, variables cancel out, and it makes a false statement, so no solution. There's no solution to make it. All right. It's good. This section's good for setting up equations and understanding them, but not very realistic. Rarely will teachers give you problems that don't have solutions to the word problems. It's kind of depressing. You kind of want to come out with an answer every now and then. All right. Take good care. Take good care. Good luck.